Find an example of two positive sequences, so the ANs and the BNs, where the sum of the ANs converges, the sum of the BNs diverges, and this inequality here is satisfied for all indices. AN is less than or equal to BN. Okay, so we just need to come up with some examples. And we don't have to be thinking too far out of the box here. We don't have to be particularly exotic. We might think, well, are there any series that come to mind that we know converge? Well, there's a bunch of them. Things like geometric series or certain p-series. Well, they definitely converge. How about things that diverge? Is there anything that sticks out? Well, yeah, again, we know how to tell if a geometric series diverges, and well, the harmonic series certainly comes to mind. For that matter, a lot of p-series also are known to diverge. So there's lots of options we could have here. Okay? We just need to exhibit the sequences and sort of justify that, yep, this one converges, the other one diverges, and this inequality is true. I'm going to go with p-series, just because they're the first ones that spring to mind. And so here's what I'm going to do. I'm going to say, let's let the BNs be the harmonic series. We know the harmonic series diverges. Okay, so that's great. That one's done. Is there a really obvious p-series that converges? Well, yeah, actually. My go-to example is always the reciprocals of the squares. But really, you know, if your favorite number was 7, you could go with 1 over n to the 7. Okay, so this converges. Okay. And if you want to, you could say, well, it's a p-series with p equal to 2, and that's greater than 1, and that's good enough for us. Okay. So the last thing we really need to justify is that inequality. Okay, well, what could we say here? Well, we're talking about indices n that are greater than or equal to 1, because we're starting all our sequences at 1. Okay. So we might say, since n is positive, okay, we can multiply both sides by n without changing the inequality. Okay, so we get n is less than or equal to n squared. And when you reciprocal things of the same sign, things that are both positive or both negative, the inequality switches around. Okay, but this is exactly what we want to show, that the BNs are greater than or equal to the ANs. So that is the last thing. So we've got a series that diverges, we've got a series that converges, and we have the inequality, and it's true for all the indices n that we consider. Okay. Now, if you want to, try it out. Try coming up with one that's a pair of geometric series. Okay. It shouldn't be too hard, actually, off the top of my head, and I'll leave this for you to verify. Let your ANs be 1/2 to the n, and let your BNs be 2 to the n. That'll work out great. Okay. See if you can find more. See if you can find ones that aren't with p-series and aren't geometric. Okay. But, well, they just asked for some examples. We don't have to get too exotic with this.